Hey everybody, I'm Hans from Diode. I wanted to share a little bit of information about how Diode Drive works and how it interoperates with the Diode Network. The whole reason we created Diode Drive in the first place was to enable a more digitally sovereign way of sharing files and collaborating on files and backing up files. We felt that solutions on the marketplace today like Google Drive and Dropbox and other solutions really introduced some elements into the whole file sharing and collaboration equation that were unintended and created liability for people who are sharing those files, and even more so in today's environment. Obviously today, when you want to use one of those providers, or even if you want to email a file to someone else, you're first uploading the file to the internet to a cloud provider, and that cloud provider is storing those files. Often those cloud providers are not only storing the files, but they're also reading the files and scraping derivative information about the files as well. And this is to enable you to be able to send a link to the file as a resident on that cloud provider that you can then provide to the person who you wanted to share it with in the first place, and then finally that person can download it. But not only now is your file in the cloud on a cloud provider who is backing it up, who is storing derivative information about that file, but it's also often storing network graph and social graph information about people who are accessing the file as well. And so you're creating a digital footprint, creating potential liability, and providing value to these cloud providers that are beyond what you probably intended to do in the first place, and definitely beyond what your desire was, which was just to share the file directly with one or more people. And so at Diode, our mission in life is to enable your digital sovereignty. And so we said, well, how would we do this? And first thing is, we have to use the internet, but first thing is don't put the file in the cloud. Don't store it there. And so when you want to share a file, your file's not stored in the cloud. You're registering the file with the cloud as a share, and it just registers a route to your computer, so that when you actually share the file with one or more people, that URL is hosted in the cloud, but the file is not. But then the person who wants to access the file requests that route and then downloads it in an encrypted pipe directly from your computer. And so this kind of gets us back to our intention of sharing the file just directly to another person. No social graph, no information scraping, etc. Very kind of elegant file sharing solution. But we also get the question quite a bit, like, well, if I'm sharing it directly from my computer, what happens if my computer's off? And this is where the concept of a sovereignty zone in Diode Drive comes in. And a sovereignty zone can have more team members, right? Like your computer can be a team member. Another of your coworkers can be a team member. A friend or a family member can be a team member. And so you can have many different team members in the sovereignty zone, all able, as a collective, able to kind of have this very resilient file sharing and resource sharing capability to the outside world. And it doesn't just stop at computers. It also includes server systems and other devices like gateways, etc. Things that that are valuable, that have valuable types of resources or operating modes that you may want to be able to leverage to create a very capable sovereignty zone. So this is all made possible through the Diode Network. The Diode Network is a collection of server nodes running around the world. It's a global, unblockable network. All of the nodes run the exact same version of software. It's open source software. The nodes don't need any custom IT administration. The security methods, because it's open source, are all auditable and clear for everyone to see, and to kind of guarantee the security of the information. And communications through the network are 256-bit end-to-end encrypted. The way in which kind of this no custom IT administration is achieved is through something called smart contracts. Smart contracts are a very common capability now in many decentralized network topologies like this. But for those of you who don't know what they are, they're autonomous and automatic contracts ran by every node on the network to be able to guarantee the operation of whatever the smart contract is created for. So the Diode Drive smart contract It does things like manage membership and the permissions of those members, and how to route shares and information about other resources in the sovereignty zones. And as I mentioned, if a team member can connect to one node, they can connect to any node in the network. And that's true if another team member connects to the same node, then great. Or if they connect to a node across the world, it doesn't matter. What happens is a virtual sovereignty zone is created that those team members are now kind of pooling and collaborating with their resources to be able to provide capabilities amongst themselves and to the outside world. So when you have that person that wants to access a file, they're also initially going to access typically the URL from the Diode network. And the Diode network, again, any node that they hit, they can get to any other part that's connected in the world to the Diode network. But from a functionality perspective, what happens is they're in essence getting that in a secured pipe directly from the sovereignty zone. And the sovereignty zone not only can provide discrete things like files and other resources, but it also has an API that can provide the ability for custom applications to also access information that is constructed from within the sovereignty zone. So for example, any regulated industry that has information stored on specific servers, those servers can be team members, and the API integrating into, for example, a medical health records system can then be getting that information from HIPAA compliant medical health record storage on these managed server systems. But then that custom application obviously can be anywhere in the world, but the storage and other HIPAA compliance security pieces are provided as part of the natural way that these sovereignty zones work. One of the neat things is inside the sovereignty zones, the resources are operating in a secured environment that enables sovereign collaborations between the team members and also allow them to share resources. So for example, if I have a team member in a geography that has excellent access to the internet, and I have another team member operating in a geography that does not have excellent access to the internet, one of those team members can communicate via the other team member to be able to gain the same level of access to the internet that they have. So not only do they pool resources like files and communications, but they also have a very resilient external footprint. The capability is not reliant on a single cloud platform provider or a single cloud app now to be able to provide files and information and static file hosting and web site information and blog information to the outside world. Those capabilities can be created and be resiliently served to the rest of the internet from the sovereignty zone. So that's a little bit about how Diode Drive works and how it interoperates with the Diode network. And we're really excited about this. The capabilities that I've talked about here are only going to become more feature-rich over time. And we believe that individuals and groups and businesses need this ability to be able to continue to operate in an emerging internet environment where having a sovereign space, a secure space that they can collaborate in, and then have a very resilient external footprint as kind of guaranteed by the Diode network and as guaranteed by the members of that sovereignty zone would enable. So please stay tuned. Get in touch with us at Telegram. We're basically on Telegram 24/7, and hit us up with any questions or comments you might have. Thanks so much.